Hey guys, Mr. Bouchard here, and I'm here to talk to you about density today. There is a demonstration that I actually do in another video, so I'm going to talk about that experiment here, diagram it out with you, but I encourage you guys to watch that video in the separate file, basically. Okay? So basically, here's the experiment. I basically took a red liquid and inverted it on top of a blue liquid. And a little spoiler here, if you haven't already watched. The red liquid, all right, I'm going to go over the smartboard to explain it. So the red liquid actually was warm water. And the blue liquid down here was cold water. Okay, and what happened, I inverted the red on top of the blue, and they stayed in place. Okay, and then after that, I turned it over so the blue was on top of the red, and then they started mixing. And the reason why they do this is warm water rises because it is less dense. Cold water sinks because it is more dense. Okay, so what we're going to do is we're going to talk about what this means throughout the lesson. All right, but this is something you need to definitely know. So warm water will rise because it is less dense. Cold water sinks because it is more dense. And this same thing happens with air also. All right, so we'll discuss this further as we go through. But that's why at first they didn't mix. And then when I turned it over, had the blue on top of the red, they started mixing because the blue wanted to sink and the red wanted to rise. Okay, so this is all due to density. All right, so let's talk about what that means. So that's what that experiment, just with clear and blue this time around. Same idea. All right, so what is density? Density basically is the combination of mass and volume. So just to remind you again, mass is the amount of matter or particles in the substance, whereas volume is the amount of space the object occupies. So density is how much matter is packed into a space in an object. There is a mathematical formula. Density equals mass divided by volume. So you can calculate density easily first by measuring its mass of the object and then finding its volume and dividing them. So mass over volume means mass divided by volume. We write out math like fractions. I'm going to be doing that also with future units, so just get used to doing it. All right, also to rearrange this equation, because sometimes you'll want to find the mass or the volume from density. So the way you can do this, I'm going to give you a quick little way to remember, is a little triangle that we can make. Density goes on the bottom left, mass on top, volume on the bottom right. So DMV, I remember, like Department Motor Vehicle. All right, so density equals mass divided by volume is the first formula. All right, you cover up D, that's what you get, M over V. If you cover up V, or volume, you're going to get mass divided by density. And the last formula, I put a multiplication symbol between D and V because mass equals density times volume. So those are the three formulas that you can get out of that triangle. It's a good way to remember how to rearrange it in case you do need to find one of the other quantities. Density stays the same for a given object. Size and shape do not affect density. So no matter how many times I cut it, shape it, I could have the size of this room, I could have it microscopic, it will have the same density because the ratio of mass to volume stays the same for a given object. So aluminum will have the same density no matter how many times I cut it or reshape it. Okay, so just remember that. So it could be cubic, it could be flat, it could be round, doesn't matter, it will still have the same density. Okay. Phase of matter with density. Solid tends to be the most dense for most substances. Some things are exception to that rule. I'll discuss. Reason why solid is most dense: the particles are close together in the object. So wood, rock, ice tend to be pretty high density. Wood, though, floats in water. So some types of wood are less dense than others. We'll talk more with that. Liquid, obviously, is going to be in the middle. Because they're loosely packed, there's no definite shape, so there's a little more motion. So again, a little lower density. And then gases obviously are the least dense. Gases float on the Earth's surface. They're very spread out, far apart, the particles. There's no definite shape. So again, least dense of the phases of matter. Density of objects. Most objects are going to be the most dense as solids, as I mentioned, and they're going to be least dense as gases. All right, one exception to that rule is going to be water, which we'll discuss in a little bit. Objects that are less dense will rise. Objects that are more dense will sink. Great example of this, hot air balloon. Okay, the way it works, you pull on that little burner on the hot air balloon. Okay, what it does, it heats up the air inside the balloon. When it heats up the air inside the balloon, that air expands out. It makes the balloon bigger. When it expands out, it becomes less dense and the balloon rises. Okay, when it wants to come back down to the earth, ground, the particles will come back together. And obviously you don't want them to do it too quickly, so obviously there's little burns you have to do to keep that from going out too quick. But the particles in the balloon will come back together and become more dense, and then the balloon will come back down to the ground. So remember, more objects that are more dense will sink, dense is down. Okay, this is a picture of obviously an iceberg. So it doesn't matter what size an object is, perfect example of this. Icebergs are less dense than water. Right, so this is a huge chunk of ice. It's still the same density as a little tiny chunk of ice. Okay, so no matter what, an object like that can float still because it is what we call buoyant. So buoyancy is the tendency of an object to float or sink. Objects that are less dense will float. Objects that are more dense will tend to sink. So ice floats in water because it is less dense than water. Metal, on the other hand, sinks in water because it's more dense than water. However, we do have iron ships that you can float in water, so we can actually shape it in a way that it will become buoyant. That's something you can actually do. Again, air is also in that factor, and then sometimes also in ships, to keep them afloat better, they'll put ballast water in the ship to help with its buoyancy a little bit. And so it doesn't tip in a certain way. All right, but definitely we can play around with floating a little bit, but in general, just the plain object, all right, whether it sinks or floats, that's its buoyancy. Okay, measuring the mass of an object, so we have to use the balance, obviously, the triple beam balance. I'm just going to remind you how to use it. So obviously you have to zero it. So the zero marking has to be lined up with the pointer with all the sliders at 0. And that little knob here on the side is how we adjust it. So if it's below the line, you're going to turn it upward. If it's above the line, you're going to turn it downward towards you. And that will actually make it zero out. You put the object on the pan. Once you get it zeroed out, move the sliders starting with the largest until and then go down to the medium size and then the small finally until it lines up with the 0 perfectly. And then read off all the digits, hundreds, tens, ones, and then of course your decimal place. So, and then units are grams, don't forget. Volume. So obviously we're going to use a formula with cubic objects or rectangular objects. That's to multiply the length times the width times the height. So length is the longest edge, width is 90 degrees from that, and then height is height off the surface. Okay, so make sure you measure it correctly and then multiply the 3 dimensions. And the units are centimeters cubed or milliliters, depending on the question. Okay, for irregular objects, there's no easy way to multiply length times width times height on them. So instead, we use something called the volume displacement method. Okay, so we take a graduated cylinder, fill it up with a certain amount of water. They chose 7 milliliters here. Drop your object in like a rock and see how much it goes up by. So it went up by 2 milliliters, so that's the volume of the object, because 9 minus 7 gives you 2. So you're putting the water in the cylinder, you're reading the amount of water initially. Remember, read the bottom of the meniscus curve. This happens to be in a plastic container, so it doesn't have the meniscus showing. And then place the object in the cylinder, subtract the 2 volumes, so 9 minus 7 gives you 2. Okay, temperature does affect density. So we can actually change the density of an object by heating up the object or cooling it down. So warm water or warm air rises because it is less dense. Okay, and that's why the warmest part of your house is the upstairs, all right, or the attic, because the warm air will always rise to that point. On the other hand, cold water or cold air sinks because it is more dense. And the basement part of your home is the coldest part of your home. Okay, so perfect example of that. Also, think of your swimming pool. The shallow end of the swimming pool tends to be warmer than the deep end of your swimming pool. And to take that a step further, the very bottom of your pool is the coldest point. The shallow end towards the surface is going to be the warmest point of your pool. And that's also how heating systems work, right? So warm air rises, cold air sinks, and it will make a circulation pattern called a convection current. All right, and we'll get more into that later on this year. Okay, pressure can also affect density. Increasing the pressure of the object can make the mass or matter closer together. This will cause the density to increase. All right, perfect example of this. Carbon in 2 different forms. So this is graphite or coal. So coal is found in the environment. It's black and it's not very strong material. Breaks pretty easily. On the other hand, diamond, that is carbon that has undergone intense heat and pressure and actually changes its form to a crystalline solid that is so dense. It's one of the hardest materials known to man. So just in general, increasing the pressure on the object could increase the density of the object, but it has to be enough to change its form, basically. Decreasing pressure allows the matter to spread out, and the density will decrease. So you could do the reverse to that also. Okay, water and density. Water is a weird substance because in its liquid phase, it's actually most dense. It's most dense at 4 degrees Celsius in its liquid phase. And it's less dense as a solid at 0 degrees Celsius and least dense as a gas at 100 degrees Celsius. Okay, so the hotter it gets, the less dense it gets. It does float in the water when it's solid, so that's another weird thing. Most things as solids will sink down to the bottom. In the case of water, it floats. Average density of water is 1 gram per centimeter cubed. And again, that's actually the density at 4 degrees Celsius, so higher and lower temperature than that, it will actually be slightly lower and higher than that. Okay, and lastly, I want to end with one thing. Ponds. So fish in a pond, basically, how do they exist, or how do they actually stay alive during the winter time? Okay, so in general, during the winter, fish can live below the ice. All right, and the reason why that is, when a lake freezes over, or a pond, okay, it's going to freeze over at the surface. Okay, so you're going to get a layer of ice up here. at the surface of the pond. And then down towards the bottom, so this is 0 degrees Celsius. Okay, down towards the bottom, it's about 4 degrees Celsius. Remember, this is the temperature at which water is most dense at. So your fish actually swim down to the bottom and exist during the winter time. And they actually go into almost a dormant phase. So they're able to live under the water during the winter time and survive the winter because they slow down their body and metabolism, and they're able to live during the winter. So an interesting little fact, but below the ice, remember, ice floats on the surface and then freezes over at the top. And that's why ponds and lakes freeze over at the surface first. They don't freeze all the way down to the bottom. All right, so thank you guys for tuning in, and I'll see you next time. All right, so this was density.